Okay, today we're going to do 5.3, which is the double angle, power reducing, and half angle formulas. So you're going to need your formula sheet. So we're going to be working with power reducing formulas. We've already done some in difference, double angle formulas, and the half angle formulas. So this is our last lesson of verifying identities and using this sheet. So we're going to go ahead and start with example 1, and it says if the sine of theta is 4/5 and theta lies in quadrant 2, find the exact value of each of the following. So before, we wouldn't know how to do this unless we had one of our identities. So before we even get started though, we're going to go ahead and draw a triangle that meets the conditions that were given to us up here. So sine is y/r, so the y value is 4, and the radius is 5 for this, not on the unit circle. And if you know your Pythagorean triplets, then this is -3. But otherwise, just use the Pythagorean theorem to find the missing side. So sine 2 theta, we're going to go ahead and take a look at our formula here. So sine 2 theta is right here. It says another way to write sine 2 theta is 2 sine theta cosine theta. So we're going to apply that to our problem right here and say that this is 2 sine theta cosine theta, which is the same thing as 2 times, well, what is sine of theta? We have it right here. It's 4/5, and cosine theta is -3/5 because cosine is x/r. And so now all we have left to do is to multiply this, and we get -24/25. And that's how you do the first one. Cosine 2 theta, let's take a look at the cosine double angle formulas. Cosine double angle formulas, there's actually 3 of them you can choose. When you're doing your homework tonight, what you're going to want to look for if you have to verify is where do I want to end up. If it has sines, then you would want to use this one. If it has cosines, then you would use this one. And if it is you don't know which one to use, you can always start with this one right here. Notice that because there's squares in there, we can substitute in the Pythagorean identity, and that's how they're creating these other two. So let's get started with part B. So we have cosine 2 theta. Because not verifying identity, I'm just going to use the first one on the sheet, but you can use any of them and get the same answer. So then we keep going. We just learned cosine squared theta is -3/5, so I'm going to go -3/5 squared minus 4/5 squared. Keep simplifying. I get 9/25 minus 16/25, which gives me -7/25. Moving on to part C, tangent 2 theta. So tangent 2 theta, you can just take it right from the sheet. It's right there, 2 tangent theta over 1 minus tangent squared theta. So we go 2 tangent theta all over 1 minus tangent squared theta. This one's going to require a little bit of math because we're going to have fractions within fractions, but it's nothing we haven't seen before. 2 over, so tangent, looking at our triangle, tangent is y/x, so it's going to be 4/3. So -4/3 all over 1 minus -4/3 squared. Follow order of operations when you're doing this. So we're going to get this right here. You can take care of the numerator, so it would be -8/3. And then take care of the denominator, which would be 1 minus, so we're going to square this, but then it's still going to be a minus, so we're going to get 16/9. Then we have to get common denominators, so this would be like 9/9. So it's -8/3 over -7 over 9. So 2 negatives are going to cancel out, and all we have to do is copy dot flip that. So 8 over 3 times 9 over 7. Reduce our fractions, and we get all of this simplifies to 24 over 7. Okay, moving on. Still not verifying an identity yet in this section, which is nice. So the next thing we're going to be doing is finding the exact value of this. And when we do cosine squared 15 degrees minus sine squared 15 degrees, what we're looking for is an identity that we can use. Since we're in the double angle section right now, I'm going to try and match one up. So if you look right here, we have cosine squared u minus sine squared u, and that's the same pattern right here, but our u ends up being 15 degrees. So why is that helpful? Well, we can't evaluate cosine of 15 degrees, but if we doubled 15, it would be 30. 30 is a special triangle, so then we can do it. So cosine squared 15 degrees is the same thing as cosine of 2 times 15 degrees. So if you want, you can make yourself a little note. You can write u equals 15 degrees. Then we have cosine 30 degrees. And hopefully you're getting good at doing these. Cosine of 30 degrees, there's our 30-degree angle. 1/2 root 3 over 2. Cosine goes with x, so the answer is root 3 over 2. Okay, moving on, we're going to verify an identity now. And so on this one right here, we are going to use some of the formulas we've already learned, and we're going to use some of the formulas that are from this section. So we're starting off with sine 3 theta equals 3 sine theta minus 4 sine cubed theta. This one gets a little bit long, but we can do it. So the first thing that we're going to do is, even though this is the more complicated side, we're going to start working this side. You guys know it can go either way. You can start whichever side you want, but I'm going to start here because I know I can do use some of the formulas with this. So sine of 3 theta, check this out, we learned this yesterday. Another way to do this is to write it like this. So I am using the sum formula right here. Okay, so if that's where you're wondering where that came from, that's the sum formula. So I'm just splitting it up so I can use that sum formula. So when you see this, I'm going to go to my sheet right now, and I'm using this formula right here. So sine of u plus v, well, my u is 2 theta and my v is 1 theta. So in my next step, it's going to be expanding it out to all of this right here. So the way that looks is, it looks sine 2 theta. I'm writing small because it's going to be a lot. And then we have cosine theta. That's from the formula, plus cosine 2 theta, and then sine theta equals the right side. So that's all from the sum formula for sine. Next, what I'm going to do is, now I see I have a double angle here and a double angle for cosine as well, so I'm going to take this, I'm going to take this, and I'm going to change them right now. So what's another way to write sine 2 theta? So looking at your formula sheet, you'll see another way to write sine 2 theta is 2 sine theta cosine theta. So all of this just came from that sine 2 theta, but notice I still have another cosine theta. So I'm going to write it right here right now, and we can write it as squared later, but for now I'm going to write it like this. Now when I get to cosine 2 theta, I'm looking to the right and I see that everything is in terms of sine, so I'm going to use the sine version of the cosine double angle formula. So I'm going to use 1 minus 2 sine squared theta, but then I still have a sine theta, so I'm just, because there's two terms, I'm putting it in parentheses. There's that extra sine theta from here to here, and then finishing off the right side. Okay, so now I'm just going to simplify. I am going to write just a little note that this was the double angle formulas. So we get 2 sine theta cosine squared theta plus, I'm going to distribute, so I get sine theta minus 2 sine cubed theta, which is nice to see since we have a cube over here. 3 sine theta minus 4 sine cubed theta. Okay, so now what I'm going to do next is, because I have a cosine squared theta here and the right side is in terms of sine, I'm going to change the cosine squared using one of the Pythagorean identities. So this is 1 minus sine squared theta plus sine theta minus 2 sine cubed theta. Once I get here, now I'm going to distribute this. So I get 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta. And you can see that this has worked itself out nicely, and we just need to combine like terms and then we're at our last step. So 2 sine theta and sine theta is going to create that 3 sine theta, and negative 2 sine cubed theta and negative 2 sine cubed theta makes negative 4 sine cubed theta, and there we have it. We get to put the check mark. Okay, now we're going to move on to example 4, and in example 4 we are going to be using our power reducing formulas. So a power reducing formula takes it from something to like the fourth power and reduces it down in powers to the second power, to the first power, etc. So for this particular one, we're asked to write an equivalent expression for sine to the fourth of x that does not contain powers of trigonometric functions greater than 1. So that means our sines, cosines, and tangents, the highest power of x is going to be 1, so it has to be to the first degree. So if you look at your formula sheets, you can see your power reducing formulas right there. So here is my formula sheet, and we're going to be looking at these right here. So we have sine squared theta, cosine squared theta, and tangent squared theta, and if you notice the expressions to the right, the highest power of cosine in each of these is just 1. So we're going to start with sine right here. So we have sine to the fourth of x, and we have to figure out how to write this without that fourth power. The highest power of x that it can be is 1. So we're going to do a little manipulation here, and we're going to write sine as sine squared of x squared. And the reason we're going to want to do this is because our formula right here is for sine squared, and we don't have sine to the fourth power, so we're going to manipulate this so we can use this formula. So once we do that, we have sine squared x squared, so we are going to take this and use the power reducing formula, which means is 1 minus cosine 2x all over 2, and then that whole quantity is squared because of what we started with. So this again was our power reducing formula for sine. So the next thing that we are going to do is we are going to actually need to FOIL this, because if I multiply this out, then cosine will still have a power of degree 2 instead of degree 1. So that's what you're going to see me do right now, is I'm going to FOIL this. So it's going to be 1 minus 2 cosine 2x plus cosine squared of 2x, I should say, all over 4. So just writing some notes here so that you can follow what I'm doing. This was the power reducing formula. For sine. And then in this step right here, I FOILed. But now we're going to have to use the power reducing formula for cosine, and this is where we have to be careful, because if you look at the power reducing formula for cosine, the angle that we're given is just a single angle, versus in our problem here we have 2x. So our theta equals 2x. So just keep that in mind when we go to use the formula and you see the next step. So I don't have to change the first part, the 1 minus 2 cosine 2x, because this doesn't have a power higher than 1. But this is the one I need to change. And again, using that cosine double angle formula right there, it's going to be 1 plus cosine of 2 times the angle. And our angle is 2x. So we have 2 times 2x. And that looks funny, but it makes sense mathematically. So this is all over 4. At this point, we are done with getting it into powers that are not greater than 1, but we do know that mathematically fractions within fractions and things like that are not acceptable, so we just have to go from there. So what we're going to do is we are going to start by splitting this into 3 fractions. So I'm going to get 1/4 minus 2 cosine 2x over 4. You can see it's going to reduce right there, plus 1 plus cosine, and I'm going to write 4x because 2 times 2x is 4x over 2, so that was our numerator, all over 4. And so then what we're going to do now is we are going to simplify our complex fraction. So this is really 4 over 1, so when I copy that flip, then I would get 1 plus cosine 4x over 8. And the last step here is that we have a 1/8 in here, so I'm going to separate this fraction because when I do, I can add this 1/8 and this 1/4 together. So I'm just going to do the math for that right over here. 1/4 plus 1/8. This needs to be multiplied by 2, so that would be 3/8. So this is going to be 3/8 minus, and I'm going to reduce that fraction, cosine 2x over 2, and then plus cosine 4x over 8. So remember that I took this 1/8 and I added it to that 1/4, but the cosine 4x still needs to be split up into that fraction so it still gets the 8 as well. Okay, go ahead and flip it over. We have 2 more problems that we're going to work on. One of them is verifying and the other is just an example. So with this one right here, this is our half angle formula. So make sure you have your sheet in front of you, because when you look at the half angle formulas, you'll see that they have a plus or minus sign on them right here. So what the plus or minus sign is which quadrant it is in. So for example, if your angle that you're asked to evaluate, your u over 2, is a cosine and it's in quadrant 2, then you would pick the negative one. So you don't pick both the plus or minus with sine and cosine. It's either positive or negative. So you're just going to pick one, and don't write that on your formula sheet because then you would be considered cheating for your test. So for this problem right here, it says use cosine 210 equals negative root 3 over 2 to find the exact value of cosine of 105. So cosine of 105 is what? How many degrees past 90? So we get this angle right here. It's 15 degrees past 90, and so this angle is 75 degrees, which is a reference angle that isn't part of a special triangle, which is why we need to use double the angle to be able to figure out what the exact value of cosine 105 is. So what should our answer be? Should we be using the positive or the negative for this cosine 105? Well, cosine of 105 is in quadrant 2 and cosine is negative, so we are going to use the negative. And I'm just going to write that so you have that down. So use negative because cosine 105 degrees is in Q2 and cosine is negative in Q2. Okay, great. So now that we know that we're going to be using this formula right here and we're going to be using the negative version of it, we have to figure out what to do. So this says u over 2, the cosine of u over 2. So what's our u over 2? So in this case, since we're asked to evaluate 105, our u over 2 equals 105 degrees. When we go to use the other side of the formula, it's not asking for u over 2 anymore, it's just asking for u. So since we've set up this little equation right here, we can see that u equals 210 degrees, which is why they gave us this information in the beginning. So now we're ready to go ahead and use the formula. So it's going to be negative square root 1 plus cosine 210 all over 2, which is the same thing as negative square root 1 plus, we know the cosine of 210 is negative root 3 over 2, so we can put that in the equation now. And so from this point, just like the last problem, it's just simplifying properly. So we're going to go negative, these need a common denominator, so this would need a 2 and a 2, so it's going to be 2 minus root 3 over 2, so that's the numerator right there, and then I still have this denominator of 2. Then what are we going to do? Well, now we're going to take this 2 and we're going to copy dot flip, because fractions within fractions are not allowed in math, only one fraction bar. So we get this, and when I copy dot flip 2, it's really 1 over 2, which gives me that. And mathematically, if you have two radicals, this is like from day 1 of pre-cal, you're allowed to split them up. So I know there's this radical within a radical, and that's actually okay. It's radical. Ha 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 ha. Okay, so anywho, this ends up simplifying to 2 minus root 3. And then no radicals in the denominator, so we get that fraction right there. So that is our correct answer. So if you plug this into your calculator, you'll get a decimal, and if you plug in cosine of 105 into your calculator, you'll also get a decimal, and you'll also appreciate those special triangles. So our very last example is to verify the tangent of alpha over 2 is the same thing as secant alpha over secant alpha cosecant alpha plus cosecant alpha. And so just like we do all of our problems, we're going to start by working the more complicated side and then switching to sines and cosines. So tangent alpha over 2 equals 1 over cosine alpha all over 1 over cosine alpha 1 over sine alpha plus 1 over sine alpha. And then we are going to keep going with this. So the tangent of alpha over 2 is the same thing as 1 over cosine alpha times 1 over cosine alpha sine alpha plus 1 over sine alpha. Then we are going to get common denominators here, so this means a cosine alpha, so we have 1 over cosine alpha all over 1 plus cosine alpha all over cosine alpha sine alpha. Oh, that's so cool, you couldn't see that last step. Well, here it is now. So we just got common denominators. Then what do? We copy dot flip. So the tangent of alpha over 2 equals 1 over cosine alpha times cosine alpha sine alpha all over 1 plus cosine alpha. The cosines, because they're common factors, those cosines are going to reduce, but this one right here is not because it's a term. So then we're left with the tangent of alpha over 2 equals the sine of alpha all over 1 plus the cosine of alpha. And if you look at your trig sheet here, which is what you should do if you ever get stuck, you see the sine of u all over 1 plus cosine u. Another way to write it is tangent of u over 2. Thus, we have verified the identity and finished our notes. Have a great day!